Hello. Okay, now what's going on is I just signed up for this video thing. Yeah, it's on YouTube, a very popular destination for many time wasters, but as well as people who would like to learn a bit about something. The whole world is full of information on the internet, and we were wasting our time on searching about famous pop stars. So this is one of these videos that really tend to make a difference, if any. Okay, let me introduce myself. Myself has a nickname in this YouTube virtual community. I choose to be my name Blind FPGA Poet. That's because I'm spending so much time on my monitor that it really sucks. Anyway, 1 minute passed and still haven't got into it. So what I'm doing now is, see that I keep everything there, and we get a very nice circuit here. I'm using Altera Quartus 2 version 6, and this is what it looks like, pretty much the folder in which my project files are, and we're looking for the Quartus design file. That's the QPF Quartus project file, that's the one. Altera Quartus is loading. This is a trial version, and okay, what we get here is bus map. Anyway, I don't understand who got this here. I don't get it. Whatever. The thing is that our goal is to use an FPGA circuit board. Let me show you this thing kind of nicer. Okay, by the way, this is a university project, so prepare to get freaked. This is a final year module. Okay, now our FPGA board is not really too much of a concern, or the pin mapping or whatever. It's the concept we are playing with here. Okay, so we have our clock here, and we want to produce some music and get some sensors. So according to what sensors reading is, the music plays accordingly. Like create an interactivity between some sensors and some output of these sensors. Nothing really exaggerated for the moment. Okay, so we have our system clock, which is mapped on pin 17, and we get counters. Our system clock happens to be 50 megahertz. This is our counter. Our counter counts has an output of 9 bits, and this is the last bit being counted, and that means that we get approximately 100 kilohertz repetition frequency, if of course the clock is about in 50 megahertz. Yeah, and now we get 4 frequencies to the speaker. We are creating the frequencies in these sub blocks. Yeah, we have our frequencies here. That means we have other counters counting on different bits and being capped on different parts of the counting. So we create sub frequencies. These sub frequencies are here, and this is a multiplexer. These are the select lines, and that goes to our B pair. It's a piezoelectric thing. Yeah, and I guess somehow this could be changed, but I haven't tried that yet to make it louder or whatever. Okay, now we get 1 Hz clock to get us help with our readings. Okay, we get an accumulator that creates according to the clock some sounds up or down, and of course these go to the multiplexer that actually to the decoder that gets those 4 frequencies played depending on what we want to play. And we have 2 black and white sensors here that feed the rest of the circuit with data, you know, get it in the logic circuits and create the interaction with the sounds and the lights. I must mention that on this FPGA board there are some lights there, nothing particularly, you know, fancy, just something, yeah. And this is our sensors to LEDs. These are the lights. We're creating something like a toy, so when our little robot supposedly runs on top of a big thing, supposed to be a fox, and it lights the lights in a way that shows it, you know, that it dislikes this, or when it walks up on top of a small thing that only occupies 1 light sensor, thinks it's a carrot, and it lights the lights in a way that we might think it's smiling. Okay, this is how it goes. We have our input sensors, we have the fox carrot interface, which gives us according to the readings if we have a fox or a carrot. We have the fox carrot LED driver that drives the LEDs, and we have the FPGA LEDs that are mapped on some pins there, and they're lighting. These are the FPGA LEDs. I have put them in this design because we're not going to be using them in anything else, so it's just the sensors to LED for the carrot and fox game. I know that on this point neither my accent might have helped you a lot, but I'm just showing you off and just telling you what I'm trying to do here. There are some blocks that we haven't used, we haven't had the time to use, like memories of how important an event is and how much this memory lasts until something else happens, which is really important to have, you know, the events gravity according to how recent they happened. All these are attempts to, you know, create something like artificially intelligent. Okay, and let me show you the whole thing now. The whole thing, it's kind of, yeah, big, yeah. This is the whole thing, our clock, our major counter that gives 100 kilohertz, our sub counters here, and the demodulator here, the piezo thing. We have other counters, the memory of the gravity of the events, the fox carrot interface, the counter that beeps, and this is a bus translation tool. Now the problem with quartus altera, the altera quartus, sorry, is that they really have a bad graphical interface. It's really tedious to get things going, not just because you're looking, you know, for the best thing with regards to logic, but it's also because if you try to move one thing, everything remains the same, or if you try to put it back, it doesn't get back. You need to sometimes, you know, go through some routine checks that really consume a lot of time in the debugging, and you know, it's hard to rearrange your space because things are left behind and you can't quite remember what was there. So that's it pretty much.